Again, we have very important phenomena as far as semiconductors are concerned. You see, now we have p-type semiconductors and we have n-type semiconductors. But have you ever thought or asked yourself, what if we combine these two semiconductors? Whenever we combine these two semiconductors, we form what we call a p-n junction. P from the p-type and n from the n-type. Between them is what we call the p-n junction. So it is a metallurgical junction between p-type and n-type semiconductors. This means that when p-type is suitable joined to n-type, the contact is called p-n junction. So this is the p-n junction, and between it forms what we call a depletion layer. This depletion layer is a layer that is free of charge carriers. Okay, so you find electrons separating from themselves, holes separating from themselves. Automatically they leave a certain zone, a certain area in which is called the depletion layer, an area in which charge carriers are absent because they are both retracted away from the junction. So we have what we call potential barrier. Potential barrier is the potential difference set up between a p-n junction. If you connect this p-n junction to a battery, you are applying a voltage across this layer. Okay, so automatically creating a layer here, it means you cause the creation of concentration of negatives here and positives here. Automatically there appears a change in voltage because huku ni more negative, huku ni more positive. Is the potential difference set up between the p-n junction due to the aggregation of the negatives on the left side and positives on the right side. Biasing of the p-n junction is the process of applying potential difference across a p-n junction from an external source. So for such a p-n junction, you connect it to a battery, so the voltage or current comes from an external source outside this p-n junction. So for such a process, when you apply the potential difference from an external source to this p-n junction, is what we call biasing of the p-n junction. So there are two types. There is forward bias and reverse bias, depending on how you connect the batteries outside the p-n junction or the circuit itself. So under forward bias, as you can see, the n side, where it consists of electrons, will be connected to the negative side of the battery, while the p side, where it is positive, will be connected to the positive side of the battery. When it so happens, then the p-n junction is said to be under forward bias, type of bias in which positive terminal is connected to the p side and negative to the n side. Under forward biasing, there is a reduction of potential barrier, because if the negative repels these electrons and the positive repels these holes, so they come close as if trying to cross this barrier. As a result, the depletion layer, as I said, it is a region where it is free of charge carriers. These charge carriers are forced to occupy this area, so there is a reduction of the depletion layer. So under forward bias, it reduces the potential barrier and hence allows current flowing. This means that the potential barrier that will be created will be smaller this time, because it has become thin. So it is very easy now for this p-n junction to allow charges to cross to either side of the junction. However, kwenye reverse bias, it becomes the opposite. The p side is connected to the negative and the n side is connected to the positive side. Therefore, the electrons are pulled away from the junction and the holes are pulled away from the junction. Therefore, there is an increase on this depletion layer. that is why under reverse biasing it is usually very difficult for PN junction to conduct electricity. It's because the depletion layer is very large, just like ilivyokuwa kwenye forbidden gap. Therefore the charges kuvuka hiyo layer inakuwa ni kazi kidogo. So this arrangement increases potential barrier, hence does not allow the flow of current. So applications is that can be used to detect the alpha particles. So the graph, if you plot the graph of current against voltage of a PN junction is in such a way as it is presented up. The more you increase the voltage, the bias, the more you increase the bias, the current increases when it is forward biased. But for reverse biased, it declines. There is a decline in current, and when it reaches at a certain level where it is called breakdown voltage, when hii barrier, kwa sababu nimesema kwenye reverse bias hizi zinavutwa huko, the depletion layer ina increase, so as if inataka kupasuka hapo. So it reach a state ambayo ni breakdown voltage. The gap will be very very large, almost breaking down in such a way it will be impossible for charges to cross the gap. So ikifika that stage ni breakdown voltage, that no matter how much voltage you increase, the current remains the same. I'm challenging you, go and read more to find the difference between knee voltage and breakdown voltage. Okay, go and find the meaning of knee voltage na breakdown voltage. Ingawa nimetoa summary hapa kwamba knee voltage ni forward voltage at which the current through the PN junction start increasing rapidly. Okay, the forward voltage in which current through the PN junction starts increasing rapidly. Okay, hiyo ndo knee voltage. Breakdown voltage, minimum reverse current at which the PN junction can conduct without damage to the current. So I'm encouraging you or asking you to go and find out more of the differences between the two. Okay, go and read extensively kuhusu knee voltage nini na breakdown voltage nini.